start. So I'm just going to start recording now, and we're going to have a little bit of fun today. I hope it will be a bit of fun because this is not really in the course syllabus directly, but it does relate to what we are hoping that you'll achieve in this course. So what I mean by that is in this course, which is about problem solving and computing, we need to have a certain way of thinking, which some people refer to as critical. Actually, critical thinking means a lot of different things to different people. I mean, if you talk to somebody in a psychology department or an English department at a university, they'll say that critical thinking, or even a science department, they might say that critical thinking is about, well, you know, evaluating the information that you get and being able to understand the sources of the information and to make rational decisions on that information, being a little bit skeptical and looking at the reasons that the information was provided to you. So, for example, we look at our sources in science and in academic ventures. So if a article has been peer reviewed, then we'll add more weight to that than we would if something that we saw on Facebook or even something on Wikipedia or something like that. So the idea is with that definition of critical thinking is about being able to analyze the sources of information and to come up with a good critical sort of evaluation of different information to make an idea of what you will accept and what you won't, and where you should do some further investigation. Of course, that's very, very important in our modern world, where we have sort of claims and counterclaims of people talking about fake news. And, of course, fake news in the United States concept, you would have come across that if you watch international news, because of the very polar, opposed political climate that they have there, which is really quite nasty. But we actually had that a little bit here in the Middle East a couple of years ago. You will remember that Saudi Arabia blockaded Qatar, and part of it, there were each side was accusing the other of fake news. Now, of course, because we're in Qatar, we know that the fake news was really coming from the other. There was that, right? And that's what started the whole thing off. And, of course, Al Jazeera would publish something that people in Dubai didn't like very much in Abu Dhabi. And then Al Arabia would publish some very nasty things that were very unfair about Qatar. And then we got to that situation. So the critical thinking how we would apply that was, okay, what's the source of that information? What their motivations, is it peer reviewed, etc. And okay, I'm going to leave it with that. Critical thinking helps you in the political domain. It helps you in the academic domain. So this kind of critical thinking I'm talking about here, and I'm going to share my screen with you. I should have done that a minute ago. Hold on. Where is my? So here we are. I can do a share screen. I should have done that a minute ago, but here we go. You can find a link on our page to this exercise, which we're calling a critical thinking exercise. And I hope you didn't mind my sort of, I hope not too rambling, but slightly rambling introduction into this concept of critical thinking, because I wanted to make sure that you're able to differentiate that kind of critical thinking, which your English teacher or your science person is going to, or your political person is going to say, well, this is critical thinking. What we're doing today is a little bit different than that understanding of critical thinking. It's more sort of analytical thinking, but obviously they're related. So here we have it. Can we solve puzzles? In other words, can we look at something here? And this one's nice because it has shapes, and I hope you can see that. And so what we see is we see a little L shaped, and then the pattern emerges as we increment the size here, right? So we say, okay, 1, and then 2, and then 3. Well, what we notice about the 1, well, 1 seems to be what? You tell me. Okay, so now's your opportunity to show your brilliance, which I'm sure you all have. How could you solve this? Then let's take it one step at a time. what would the object that's going to go in the block that's labeled 4 look like? And you can just describe it.
And just add a block on each side.
Very good. Not sure. So that was Lo Jane. So in other words, you'd say, whereas this block has 4 stacked on it and then is 4 wide, that this one would be 5 stacked and 5 wide. Is that what you're saying? I think that's what you're saying. You said just add a block to it. So you'd add a block to both directions, so wouldn't you, to the X and the Y? Correct?
Yes, sir.
All right. So what about in the number 5? What would it look like?
Add another block.
All right. So it would be a total of how many blocks stacked on top of each other?
Number 5 makes 6 blocks on top.
And how many across?
6? No, yeah, 6.
That's right. So here we have 2 blocks tall, 2 blocks wide, 3 blocks tall, 3 blocks wide, 4 blocks tall, 4 blocks wide, 5 blocks tall, 5 blocks wide, 6, 6, 6. And so this would be number 10 would be how tall? Now we're not adding a block. Now we're looking for the pattern. So the number 10 would be, what would be the shape?
11 on each side.
Somebody's, yes. Okay. So yes, 7, 7. Yes, it would be correct. You're right. It would be 11 tall and 11 wide. So can you identify the pattern? Could you, for example, write a formula for that pattern? If you did, what do you think it would be? So if we said that the number along the bottom there is n, then so this is where n is 1, this is where n is 2, n is 3, n is 4, n is 5. All right. So the total number of squares here. So now we're going to look at the total number of squares. In number 1, the total number of squares is 3. So how would that relate to n? Where n is 1, the total number of squares is equal to n. Well, it's n plus 2, isn't it? Right. So if n is 1, then the total number of squares is n plus 2. But if we look at this one, maybe that pattern is a little bit different, right? So where we've got n is 2, then the pattern is going to be 3. Hold on, this is going to be 3 plus 2. So how do we get from 2 to 3 plus 2? I think that we need to go back and reevaluate that formula. So maybe it's, so how we actually do it, if you remember what was happening there, what we had here is, if you start off with 1 block here, you would add 1 to the top and 1 to the side. So that would be 1 block plus 2 times that block, right? And so if you had, when you get to 2, what you do is you add 2 there to the original block and 2 there. So that's like 2 times n to get 4 plus 1. See if that makes sense. Then this one would be 2 times 3, which would be 6. Those 3, and those 3, plus 1. 2 to get the 2 because 2 sides, right? The top side and the bottom side. 2 times 3 plus 1. Does that make sense? And then so now for number 4, let's see if I've got the pattern right. I would say 2 times 4 plus 1. That would be 9 blocks. Now it would be, as you said, 5 blocks high and 5 blocks wide. The 5 blocks high, that's 5. The 5 blocks wide, but we don't count the first one because that was already counted in the high. So that would be 9. And how can we get that simply in mathematics? We'd say 2 times 4 plus 1. 2 times 5 plus 1 would be 2 times 5 is 10 plus 1, so that's 11 blocks. There should be 11 blocks here. 6 high. 1, 2, 3, 4, 5, 6, 6, and then 6 wide. So add another 5 to that 6, that gives you 11. And how many blocks total? You guys haven't gone to sleep on me yet, have you?
12.
No. How many blocks total? You're going to have, it's going to be 11 high and it's going to be 11 wide. So it's going to be 11 plus 11 minus 1. Or we could say, so 11 plus 10, or we could say 10 times 2 plus 1, 20 plus 1, 21. Oh, okay, so I want you to see if you could, so I reckon, by looking at that, I reckon I see a formula that I could put in mathematics. Now, this is the thing, right? If you were writing a computer program to build this, that's what you would do, right? You'd say, okay, enter in the number. They'd enter in the number. You'd call it n. Then you'd say 2n plus 1 is the number of bricks. Or else you could say, take n. So you take 1, then add n number of bricks to the top and n number of bricks to the side. First one is always stable, and we add number, and they write up to the right. Yes, that's fine, Waleed. I like that one too. So if you were building it with a computer, that's kind of how you would do it, I suppose. And computers, I think I mentioned this to you in the first lesson, computers aren't really all that smart like humans. You know, you've got like 5 different ways of looking at this and coming up with a solution. And your 5 different ways, you know, some of them might not be so mathematical. Some of them are just going to be you looking at it and you sort of seeing the pattern without actually going through the mathematical process. The mathematical process is actually making it a bit more simple. We actually call that abstracting. We take something which kind of looks kind of complicated. You know, these shapes could be kind of weird. Kind of looks kind of complicated, and simpling it down to the simplest sort of possible way so we can express it with the least number of words or the least, and mathematics does that perfectly. I mean, we hardly use any words for that. But in mathematically for this, we can do that so nicely, this 2n plus 1. Or you could say 1 plus 2n. Or you could say 1 plus n, right? Because 1 plus, take the number n up there, and then take the number n that way. So maybe that would even be better. 1 plus n up plus n right. But yeah, and that is the way that Waleed expressed it, and I like that. So Waleed's teaching me something here, and I appreciate that. So that was a good way to express it. And to be fair, I think probably Waleed's explanation there is probably better from a computer point of view. If in the computer point of view, you wanted to actually be able to draw this. Mine was a little bit more simple because I don't know why, but I was just thinking about the numbers. So Waleed had a better answer, I think, because his was looking at the shape. And so the shape required that you go up and you go right. Very good, Waleed. Thank you so much for that. As I said, I learned something from that exercise from you. And as I said, you know, perhaps I was a little bit too invested in the idea that I wanted to make this as simple, take a complex idea and make it into something simple that we could sort of apply some mathematics to it. And maybe there was a bit more that we should do there is actually look at some dimensions as well. So very good. And of course, the very good mathematicians would know that we could do that with things like vectors, stuff like that. Wow, awesome. Thank you, Waleed and Lojane. That was a very good sort of contribution that you guys made there. Now, I would say that, so my original formula was going to be 2n plus 1. I think Waleed sort of improved upon that, and I would say that now we would be better to go with something like 1 plus n up plus n to the right. And I think that would be a better one, which, you know, if all you wanted was the number of blocks, then my formula would have been fine. But if you wanted to actually represent how those blocks are shown, then that would require something that you guys did. So very good. Thank you, guys. All right, let's, are you guys happy with that? 2n plus 1? or 1 plus n up plus n right? You guys okay with that? You got the idea?
Yes, sir.
All right, so I think we solved that one. Thank you guys for your participation on that. I don't know if I should go through all of these. Maybe I should leave some of these for you to sort of work on and be happy to work in a group. Now, I think we put ourselves in a WhatsApp group, right? Is that right?
Yes.
Yeah, I think we did. So is there anybody in this who's listening now that's not in the WhatsApp group? Or is the person who created the WhatsApp group here?
I created it, sir.
Jane, thank you. Anybody not in the group? Because maybe you want to discuss this amongst yourselves in a minute, because I don't think I'm going to go through them all. Yeah. Abid, could you give your phone number so Jane can add you, or else maybe she can just send a link one way or the other, so that make sure that you sort of get in on the communications. That'd be good. Right, let's do one more together. Got a package of nuts, and see if you can sort it. So as I said, we try to abstract it. In the last problem, I probably abstracted a little too much. And so the other guys sort of semi-abstracted, and that got us to a place which was sort of pretty good, I think. But what we want is we want to get we've got a total number of nuts. We know what the total is. It's 81. But we need to know, what is the breakdown? How many for each nut? Okay, and so everything seems to be referenced around cashews. And this is what I mean by that. Cashew nuts, Brazil nuts represent twice as many as there are cashew nuts. So whatever number of cashew nuts there are, there's twice as many Brazil nuts. And okay, now, the next thing that we notice is whatever number of Brazil nuts there are twice as many of peanuts, or peanuts represent twice as many as our Brazil nuts. So I hope that you can, so keeping these things in your mind, so this is part of the sort of the abstraction and keeping things in mind. So what I can see here is the number of Brazil nuts is equal to 2 times the number. We could say that B is equal to 2C. I could say that, I think. B is equal to 2C. And then if I said P is the number of peanuts, well, P would be equal to B. B is equal to 2C. P is equal to 2B. And A for almonds is equal to B for Brazil nuts. Now, I think what you need to do is see if you can find something in common. This is a type of problem that sort of comes up in sort of, again, it's mathematical. But the way that you would solve this, I think they call this simultaneous equations. So what we could say is if we took all the nuts, the C plus the B plus the P plus the A plus B plus C plus P, that's all going to be equal to 81. All right, so I've started. If any of you guys got looking at this, and it is maybe it's a little bit harder than the last one. This is getting into the territory that I jumped to too quickly, perhaps, which is straight up abstraction, numbers, maths. We're not drawing cashews or lining them up or anything like that. We're just saying, what is the number of each one? So it's just math. Anybody got sort of a start on this? Can you remember your simultaneous equations from any time in your past history of life? I know you notice in the degree they're making people do a calculus course, which in order to do calculus, you kind of need to be able to do this sort of algebra stuff. So what we got here is simultaneous equations, which is kind of a sort of a basic algebra stuff. Anybody want to make a contribution on that, or? I would give you a bit of a clue. I would think that the thing that everything kind of relates to is cashews, right? So Brazils are twice as many as cashews. Peanuts are twice as many as Brazils. Yeah, 2 times Brazil nuts is equal to the number of peanuts. almonds are the same as Brazils. So you could say, you could just put everything as C. So how many cashews are the Brazil nuts? 2. So you could say, you know what? Can you guys see my form? Can you guys see my? Yeah, you can. All right. So what I'm going to do is this. Sorry, the pencil. Maybe you can see this. So this is what I think. I think the total is equal to 81. Total is equal to 81. I don't know if you can see that. Right? Backwards, right? That's right. The total is equal to 81, but the total is made up of cashews plus Brazil nuts plus peanuts plus what was the last one? Almonds. Now what I've done there is I've converted everything to C's. So what I've said is almonds is the same as Brazil nuts. And what we know is Brazil nuts is 2 times the number of cashew nuts. So almonds is 2C. Peanuts is 4C. Brazil nuts is 2C. And cashews is C. So now I've got something and everything is using the same symbol. So I can do something with that. I can see that it's 2 plus 4 plus 2. That's 8 plus 1. That's 9. So 9 times C is equal to 81. Now you're good with your basic algebra. You're going to know the answer, right? So the answer is going to be 81 divided by 9 is equal to C, right? That's your sort of algebra moving things around. And so straight up, 81 divided by 9 is equal to C. So C is going to be equal to 9. There's 9 cashews. And so there's 9 cashews. So that means there's 18 Brazil nuts. And that means there's 36 peanuts. And there's 18 almonds. So 18 plus 18 is 36, plus 36 is 72, plus 9 is 81. Magic. How mathematics is magic. Isn't that wonderful? Sorry, I kind of solved those for you, but it's kind of good. And Noman got there 455. That was like a minute ago. That was before I gave the answer. He beat me to it. So there you go. You guys are onto this. It's not really that hard for you. That's good. So what I'd like to do now is we have some logic. Good. We solved that problem. 9. There's 9 of cashews. There's 18 of Brazil. There's 36 of peanuts, and there's 18 of almonds. We solved that. Last one that we'll look at today, because I'm going to leave those other 2 for you guys to do. That's kind of sort of like a fun exercise. But I think I'm just going to start this without finishing it. Now, when it says logic here, it's talking about the logic of arithmetic logic. And this arithmetic logic, why are we using arithmetic logic, right? So why does Mark keep talking about mathematics? Because computers are dumb, man. They can't think about, oh, today was a beautiful day. I love the sunset. Doesn't mean anything to a computer. Might mean something to you. Doesn't mean anything to a computer. 10 plus 8, computer can do that, right? They're not really very smart. They're not like people. So we have to sort of break things down to the smallest, sort of simplest way. And our basic abstraction of math, that works nicely with computers. They can do that good. And actually, that's why we use computers, isn't it? We use computers because they can do that good. Not only can they do that, okay, because we can do that too. I mean, we had to be able to do it to show the computer how to do it. But the thing about the computer is it can do it really fast, really, really fast, like millions of those types of things in a second. And that's why we use computers. It's not because they're smarter than us, just because they're fast, a lot fast. Anyway, so if we can give it the right instructions, it can do all kinds of fast things for us. Like, for example, what you're doing now is watching something on a Zoom. That's all computerized, right? You can hardly believe the amount of sort of mathematics that's gone into that, right? I mean, you think, oh yeah, all you do is, a bit of HTML here, a bit of Java code there. There's no math in it. Oh, there's a lot. There's a lot, but it's been done in the first generation language at the operating system level. It's done for the last 60 years, we're standing on this mountain of computer understanding, and we're writing our code on top of that. And yeah, there's a lot of math underneath it, that's for sure. All right, so what we got here, I think is different. I've never seen Fatma spelled like that before. So I looked at this and I kind of guessed that that might be because what we're trying to do is we're trying to get the letters of the names of the people to sort of line up with the letters of the names of the subjects. So there you go. But don't be fooled by that, because what it says here is the favorite subject does not begin with the same letter as their name. So what it wants is the favorite subject of all of these people. And so Ahmed, his favorite subject cannot be art. It's got to be some other one, right? Likewise, Badr, his favorite subject cannot be biology, but it could be art. Miriam, her favorite subject cannot be math, but it could be some of the others. So this is the logic that we're talking about. Very simple mathematical, and so it also works in our computer language logic, which is basically true and false. If it's false, it can't be true. If it's true, it can't be false. That's all this means. So what this means is if Ahmed his favorite subject can't be art, then it can be some of these other things. So what are some other things about Ahmed? Well, then we have to look through these other bits of clues and do that. And it's all going to be on, is this true or is that false? Is that false or is that true? And by doing that, we're able to sort of limit things down and come to an answer. Now, there is an answer. I did work through this. There is an answer to this. But what you have to do is you have to look at each of these individual things and sort of apply them. Now, what I would do is I would write the names of each of the people down on one side, and then I would sort of maybe beside them cross out or eliminate the things that they couldn't be. And by doing that, you can narrow it down to the things that they could be. Oh, well, actually, here's one. It's not just about the things they couldn't be. There's a good one on the things that they could be. I think I might even start with Miriam, right? So I'd write all their names down. Ahmed, Badr, Miriam, Fatma, Sami. But I look here and I see that Miriam is very talented athlete. Very good moment. I am going to put physical education beside Miriam. Miriam's physical education. And this gives us some more information. What that means is that the favorite subject of Ahmed cannot be physical education. The favorite subject of Badr cannot be physical, okay? The only person who the favorite subject of physical education can be is Miriam. So we've got a start. I would put those names down there. I don't know. But what I would do is, as I said, I'd put Miriam, let's start at the top. Start Ahmed, Badr, Miriam, Fatma with a PH. Maybe Fatma is a Greek Fatma. They use a lot of PHs. And Sami. And so what we end up with is we've got Miriam with physical education. So we've got 4 other subjects that we need to put in there, right? So away we go. Is there any other? Badr and the person whose favorite subject. So that's nice. So the only thing that I would gather out of that is that I would say that, they probably have some commonality, but I wouldn't attach too much to it. Now, this other one, Sami, I cannot draw a straight line with a ruler. When I looked at that, I said, well, yeah, he doesn't like math, right? Because in math, you have to be able to draw a straight line. The other thing is he probably doesn't like art. So for me, I said, well, Sami, he's not in art, he's not in math, or those are not his favorites. And Miriam, we've satisfied Miriam, we don't have to worry about her. Now Fatma and Sami don't like experiments. So that means they don't like science, so they don't like biology. So that's the clues that I would have got from that. So Fatma and Sami are not going to be biology. Somebody else has to be biology. So, I mean, you could just take the biology now and say, okay, biology. It can't be Fatma and it can't be Badr. So it could be Ahmed and it could be Sami. Is there anything else about Ahmed and Sami that would disqualify them from biology? So Walid thinks that, okay, what do you think with Sami for what, Walid? Would Sami be biology, or would Ahmed? So is there anything else about Ahmed there? Could be either of those at that, right? Couldn't I? There's one. So biology, maybe, yes, because he doesn't hate science. The ones who hate science. Oh, so Sami hates science. Sami can't be biology. So biology must be Ahmed. I'm going to put biology for Ahmed because Sami doesn't like biology, and so that leaves Sami to be. What does it leave him to be? You see what we're doing? We're just doing a process of elimination. So who would be math? We were going with Badr's person in social studies. I think maybe Badr could be math. Sami couldn't be math, and he couldn't be art. But Badr, is there any reason why Badr? It's social studies. Oh, social studies is there, right? So what we know is Badr is not social studies. We know that because he sits in the thing with social studies. So is there anything about social studies that would indicate that it would be either Fatma or Sami? I don't think so. It could be either of those. Yeah, we've only got 3. We got 2 people placed. So there's 2 more people to do.
Is it Fatma?
Why do you think Fatma?
Why do I think Fatma?
Fatma for what?
Social studies, maybe.
Okay, so why? Let's put Fatma for social studies and see what will happen. So I got Fatma for social studies. That's 3 people placed, and so that leaves us with Sami and Badr. Okay, so Sami can't. What's left is math and biology. Now that won't work because Sami doesn't like biology and Sami doesn't like math. So he can't be. So we can't have Fatma for social studies. I think I would put Sami for social studies, and then that leaves Fatma and Badr to fight over math and art. Now, math is like science, or science has lots of math in it. And when you do experiments, I think you have to do some math. So I'm going to say that Fatma is not going to go with the math. So I'm going to give the math to Badr, and I'm going to give the what's left over, which is what's going to be for art. Now, that's the way I did it. Now, how do I know that Sami doesn't like biology? Very good question. Because he doesn't like experiments. Biology is science, it's experiments. Okay, so I think I've got a logical reason for all of those things. Let me go through and explain them. All right, so Miriam likes phys ed. That's pretty clear. She's a talented athlete. She's in the volleyball and track team, so she likes phys ed. Ahmed, I'm putting him down for biology, and that was basically by a process of elimination because biology couldn't be Sami and it couldn't be Fatma. All right, and yeah, okay. Now when I looked at Badr can't be social studies. Did not said she liked biology. Yeah, all right. Badr can't be. And so the social studies has to be some other person. I put Sami as the social studies because Sami couldn't be art or math. And so somebody else had to be art or math. Now, why couldn't Sami be art or math? Because he can't draw a straight line. Yeah.
Well, he was joking. He wasn't serious.
Oh, well, but I mean, that's, yeah, it's, we are working with very limited information here. And so I think, yeah, so we don't know for sure, but I think I came up with a logical. Does that make sense to you? I hope. So that's a little bit of logic. Just to summarize, what that logic was doing was true false, which very nicely represents what happens in a computer, because we say that the basic of our computer systems is the binary programming and the binary numbers. Binary means that there's only two. Bi means two. Two numbers. The two numbers that are the basis of all computing are 0 and 1. And 0 and 1 very nicely represent the idea of true and false. So that's binary. Some people don't like binary, but binary is a very, I mentioned that computers aren't too smart. And at the very, very bottom of it, what we end up with is, yeah, just true, false, true, false, true, false. All our numbers are that. And then based out of that true, false stuff, we actually build up big numbers and we build up big computer programs. The others are kind of fun, but maybe I'd like to let you guys have a go at it yourselves. What do you think? What do you think? You don't have to memorize the binary numbers, but it would be good if you learned them. And the binary math is kind of strange. You're right about that. I think that that's kind of enough for introduction. What do you think, guys? So what I want to do is I want to stop on this now. I want to leave you with this. You'll find a link in your D2L to this exercise so you can continue with it. And I want you to just have a go at that. Now, this is not an individual exercise unless you want it to be. So in other words, I don't mind if you get together